During my first semester at MIT, I got computer vision software that was supposed to track my face. It didn't work until I put on this white mask. I'm thinking, all right, what's going on here? Is it the lighting conditions? Is it the angle at which I'm looking at the camera, or is there something more? That's when I started looking into issues of bias that can creep into technology.
Our ideas about technology that we think are normal are actually ideas that come from a very small and homogeneous group of people.
Vast amounts of data at incredible speeds.
Everybody has unconscious biases, and people embed their own biases into technology.
This kid got stopped as a result of facial recognition misidentification, and then used that as justification to search you. This is an innocent child.
Racism is becoming mechanized.
Systemic issues are only going to be hardwired into new technologies.
It's not just face classification, it's any data-centric technology.
Every day, we are all being scored.
Who gets hired? Who gets housing?
I am making predictions for your life right now.
The people who own the code deploy it on other people, and there is no accountability.
Management analytic towers wanted to install the facial recognition software. Pretty much turn this place into Fort Knox.
The technology is being rapidly adopted, and there are no safeguards.
We are socially controlled in a way that we don't see.
Technology that analyzes faces could be biased, but the company is pushing it anyway.
What demographic is it most effective on?
White men.
Show me that it's going to be fair, that it's legal, before you put it out. That's what we don't have yet.
It's going to take people coming together, striving for justice in this age of automation.
Hey everyone, and welcome to week 2 of TWIMLfest. Super excited to have you all here. How'd you like that trailer for Coded Bias? That is just one of the things we've got on tap for this week. On Saturday, starting at 10 a.m. Pacific, we'll be hosting a group watching on Slack. And then at 12:30, we'll be going live with a panel discussion featuring the director, Shalini Kantaya, Deb Raji, and Meredith Broussard, both of which you saw in the trailer. If you can't watch with the group, the screener will be available Wednesday morning through Saturday for you to watch on your own. You'll be emailed the link and password if you click interested or going in the agenda. Some other things that should be on your radar for this week. We had a great kickoff last week of our Code Names and AI for Good hackathon competitions. The AI for Good hackathon, in particular, I've got a submission on the leaderboard there. Very interesting NLP focused competition. I encourage you to check both of those out and participate. Very easy to participate in. We've also added a bunch of community submitted submissions sessions to our agenda for this week. So on Friday will be AI and machine learning and physics hosted by G. On Thursday, checklists for NLP models hosted by Michael. On Thursday, the 29th, we've added what it means to be the lone ML engineer at a startup, hosted by Manjush. And also on Thursday, the 29th, doctors and how talking to them changed my own beliefs about the role of AI in healthcare, hosted by Ranga. I encourage you to check these sessions out on the agenda and keep checking the agenda frequently as we continue to add new sessions. Also new on the agenda is a StyleGAN workshop hosted by Derek Schultz, who is an AI artist. He'll walk you through using StyleGAN to create art. And there are limited spaces for this workshop. So if it's something you're interested in, please note it on your agenda. Last week, we had the first of our ongoing series of office hours here at TWIMLfest focused on NLP. That was a great session with a lot of great questions and discussion. This week's session will be focused on reinforcement learning. So be sure to check that out if you're interested in or curious about RL. A final update, the trivia competition has been moved to next week. So you've got another week to brush up on your AI and pub trivia in advance of that competition. And you can use this time to start forming teams. I wanted to send a quick note of thanks to our sponsors for TWIMLfest. These folks are not just TWIMLfest sponsors, but they are really supporters of many of the things that we do here at TWIML and our community at large. They are IBM, Tecton, Prosus, Appen, Cloudera, Microsoft, LinkedIn, Paperspace, and Qualcomm. Please join me in thanking them and checking out what they're up to. All a bunch of really interesting companies. So without any further ado, I would like to get our keynote for this week, our opening keynote for this week started, and welcome on Jeremy Howard, founder of Fast.ai.
Hi there, Sam.
Hey, Jeremy, welcome back to the show. It's great great to be on with you once again. I first had you on the podcast. It was actually a couple of years ago around this time. We were talking primarily around about Fast.ai version 1. And then a couple of months later, you joined us for our AI Rewind series, and we talked about trends in deep learning. And I suspect we'll catch up on all of that stuff this time. But once again, welcome back.
Thanks so much.
How's everything been going?
Yeah, it's been great. I think last time we chatted was actually at Europe's in Montreal, and yeah, it was exciting to have some software out there, and particularly at that time, our NLP research. I was excited that I thought that this crazy idea of using language model pre-training could actually go somewhere, and that certainly turned out to be the case. Since that time, it's been a really unique time in Fast.ai's history, which is that I stopped doing courses for 18 months in order to focus on building the most solid platform I could. During that time, Sylvain Gouger and I wrote Fast.ai 2, which is a rewrite from scratch of the library, and a book. And then we put out a course with all the material from those two things. And in that time, we built a pretty complete platform for data science, machine learning based coding and publications. So we released something called Nbdev, which is a complete framework for building software and documentation in notebooks. We released something with Hamel Hussein called Fast Pages, which is a system for using notebooks to create blogs and articles. We created Fast Doc, which is something for using notebooks to write publication quality books, which we used to write our book. And Fast.ai 2 itself turned out really successfully. It turned into an academic paper describing the unique layered API it provides, which really allows both beginners and experienced researchers to really quickly reach and go beyond best practices.
Awesome. Well, we will touch on a bunch of that in more detail, but before we dig in, I'd love for you to spend a few minutes kind of level setting everyone on your background. We've gone through your background in the prior interviews. I tend to remember it as you were a McKinsey consultant at age 12, you joined Kaggle at age 14, and then you founded 3 deep learning companies by age 16.
No, nothing like that. I was at McKinsey when I was 18. and I stayed in consulting for nearly 10 years, which was not my plan. I planned to be an entrepreneur. That was my hope, and I planned to be in consulting for 2 years. And as one does, I got mixed up in the rat race, and found myself wanting to reach the next level of that consulting career. And so I think 2 years would have been a great plan. Nearly a decade is far long to be in consulting, but I think it's useful background to understand business strategy and logistics and processes and HR and stuff. And then, I started 2 companies, which was an email company called Fastmail and an insurance pricing company called Optimal Decisions. They both went well. They're both still going strong. And then helped Anthony Goldblum get Kaggle started. And then, one of the interesting things at Kaggle was, as the chief scientist there, I was involved in creating all the competitions and involved in studying all the solutions. And I had not really done much with neural networks for 20 years at that point, but I always thought at some point they'll come back. At some point, we had quite a lot of success with neural nets in the mid-90s on kind of marketing campaigns and stuff, but particularly after random forests came along, I felt like this is just much faster and more convenient and cheaper. It cost millions of dollars to buy the hardware needed to run a neural net in the mid-90s. Wow. But at Kaggle, I saw in 2012 winning solutions starting to appear to competitions that used neural networks. But now they weren't single hidden layer nets anymore. They were deeper nets. Deep learning at that time meant maybe 5 to 7 layers. So I was pretty excited. I felt like this is what I've been waiting 2 decades for. And so that was when I started Analytic, which I thought was, which was deep learning in medicine. I thought that was the biggest low-hanging fruit for impact. And I really wanted to show people that deep learning can make a difference in medicine. And that was super successful. Today, the use of deep learning in medicine is pretty well established. It's still being developed, but it's pretty well understood. But I guess I felt like that was just one little thing. It was not, there was so much more we could be doing, and it was far more than I could do myself. So that's when my wife Rachel and I started Fast.ai to try to be a much higher leverage, like make it so that hundreds of thousands of people can build their own analytic, but in whatever field they were passionate about, whether it be journalism or disaster resilience or access to water or legal or whatever. That's how I got to there.
Nice. You mentioned that the insight that led to you starting Analytic was kind of seeing some low-hanging fruit. And I'm wondering, where do you think we are in the machine learning adoption cycle? I think everything's kind of mixed up and confusing now with the pandemic, and a lot of people are I think projecting things that they're seeing with the pandemic on the machine learning AI market. I see that conversation on Twitter sometimes. And I'm curious where you think we are. Is this kind of a breathing period that we're in, driven by COVID and everything that's happening there? Are we still at the very beginning? Is it maturing? What's your take?
Yeah. Every significant sized company is using AI somewhere now, pretty much. So it's very well established at this point in some certain areas. But I'd still say it's very early days. And one of the reasons it's very early days is that it's still too difficult and data intensive and compute intensive. There's a lot of people who got their start through Fast.ai courses who are now running groups at big companies, and they're hiring they're often hiring Fast.ai alumni, or writing their own books or their own courses. And so we're certainly getting a spreading of knowledge, but we need to make things simpler. It takes really well over 100 hours of study, even with the Fast.ai book or courses and software to be a practitioner, and that's assuming you've got a really strong coding background. That's just too long. It's also tough that a lot of folks in management positions, they were around before the AI revolution started, so they don't understand it. They don't know how to hire the right people. They don't know how to kind of sort through the bullshit, whether it be from vendors or whatever. So yeah, there's a lot of steps that we need to go through to allow, the average company to do the kind of stuff that the Facebooks and the Googles are doing right now.
And so I think that sounds like still early on, but demonstrably kind of well accepted.
Yeah, that sounds right.
And so what do you think that means for folks that are just getting started? They, haven't started with deep learning, maybe not even with machine learning. They've come across maybe one of your courses or one of the study groups we offer through our community, and they're wondering, is this something that, they should still be investing in?
Yeah, I think it's critical. In nearly every field, there's an increasing gap between those that can speak and do AI and those that can't. And it varies by field, but domain experts who also understand how to practice deep learning are really, really highly valued. They can start startups and quickly get huge amounts of investment. They can get employed, at vastly increased salaries, because what they can do is they can bring their domain expertise, whether it be in legal or medicine or whatever. They can combine it with this incredibly leverageable, powerful toolkit. So to me, it's, if you've got to the point where you're asking yourself the question, is it worth investing in learning AI and deep learning? The answer is almost certainly yes. Not so that you can become an AI person, but so that you can add that to your existing toolkit and become a AI-enabled X, where X is whatever you're already good at.
So you've mentioned kind of a bunch of things that are new with Fast.ai and some of the things that you've worked on. Let's maybe, dig into the latest version of the library. And, now that that's out in the market and you've kicked off courses with it, you've written a book about it. How's that going?
It's going great. I love hearing about all the stuff that people are building with it. So I have an alert set up to tell me every time somebody publishes another paper that cites Fast.ai, the library, and it's a continuous stream of cool stuff, particularly in the bioinformatics and proteomics kind of space. Fast.ai is kind of huge, particularly people combining it with ULM-Fit, because Fast.ai certainly provides the most capable ULM-Fit implementation. We hear a lot of our students saying that they've brought Fast.ai into their companies, and it's allowed them to, a lot of people are saying like, oh, our company used to use TensorFlow and Keras, and we switched over to Fast.ai, and all of our models immediately became more accurate and less code to maintain and to understand, and that we're building on top of them faster and easier. Also because this really important thing, which is it's a layered API, so you can go deeper and deeper and deeper, and at every point there's a delightful API for you to use. we're getting more and more, we're seeing more and more people becoming experts at the deeper levels of those foundations and are able to contribute pretty substantive foundational improvements to, for example, there's a computer vision library which is entirely GPU accelerated that we wrote from scratch, and people are adding in new augmentations or improving the computer vision primitives. It's really fun. It's really exciting to see.
Mm-hmm. And it was last Fast.ai v1 that was a rewrite from TensorFlow to PyTorch. Is that right? Yeah.
So Fast.ai v1 was a pretty simple, relatively thin layer where the course had originally been a TensorFlow. Well, it's originally a Theano course, and then it became a TensorFlow and Keras course. And we moved part 2 of the course to PyTorch because trying to do the research level stuff in Keras was just too clunky. This is just when PyTorch came out. And so that became Fast.ai, the library 0.7, which was a really thin little level of utilities to simplify a few things, because PyTorch, particularly at that time, came not at all batteries included. It was really something you built things on top of. And then when we realized that we really needed to use PyTorch for part 1 of the course, which is designed for absolute AI beginners, we realized that we couldn't just do it in raw PyTorch, because that, to create a network required, subclassing and object-oriented principles. It required writing a training loop from scratch. It required, updating the weights with the gradients, like way too much stuff for a top-down approach where you want to say like, okay, let's train a model. Okay, click train, here we go. Mm-hmm. So that's what Fast.ai v1 was. It was kind of the minimum necessary that we could to get people up and going with PyTorch. But in practice, once they went beyond that, they were generally going back and doing stuff in pure PyTorch to really build much further. So V2 is really all about saying, like, when you're ready to get the next level deeper to like improve your performance, speed, accuracy, make it work on more data types, whatever. Every time you go one level deeper, you'll find a really nice, clear, beautifully designed API to work with. And at every point, you can always integrate with pure PyTorch, Torch Vision, other training loops really easily. So for example, when you download Fast.ai, it comes with a number of notebooks showing you how, without any changes to your existing code, you can upgrade from pure PyTorch training loops, Catalyst training loops, Ignite training loops, whatever. Fast.ai integrates with all these other things really easily. It comes with a notebook showing how to use transformers with it. It comes with a notebook showing how to use Torch Vision with it. It comes with a notebook showing how to use augmentations with it. So it's really, it's really easy to just grab the bits that you want and delve as deeply as you want, while still providing the same 4 lines of code to run one of the built-in applications.
Sounds like you're pretty happy with the decision to shift over to PyTorch. I still see that question come up all the time: TensorFlow versus PyTorch. Is your answer to that PyTorch, or is it Fast.ai?
Yeah, it's PyTorch, but I wouldn't use PyTorch raw. There's so much that Fast.ai does for you that the chance of you getting all of those things right yourself is pretty small. How do you deal with batch norm layers when you do transfer learning? How do you deal with discriminative learning rates? How do you deal with which layers are meant to have weight decay and which aren't? There's so many things to do carefully yourself. And I don't think I've ever seen a research paper code library that does even the majority of those things correctly. So we pretty much find we can always dramatically improve any project, deleting about 2/3 of the code and getting dramatic improvements to the performance. So I'd say, yeah, start with learning Fast.ai and learn PyTorch well. Like I described, Fast.ai is designed to be something which gives you really convenient access to the PyTorch machinery as you need it. And our view is to learn something, to learn deep learning, do it through projects. Like don't procrastinate the start of projects by spending months relearning linear algebra or calculus or the entire API of PyTorch or something. Like build something right now. Like I said, it's only 4 lines of code to get started, and then you're experimenting, you're iterating. You can see whether whether it works for you and how it works. And so many people tell me they make the mistake sometimes for years of procrastinating actually practicing deep learning by just delving deeper and deeper into the foundations and the theory. And I've almost never heard a practitioner tell me that they did that and they're glad they did. That's stuff that you want to learn eventually, but you should learn it in the context of your practice and your development.
Mm-hmm. Mm-hmm. Well, that's the foundational idea behind the deep learning for coders approach, contrasted with the more traditional, like a Stanford.
Yeah, and it's important to realize it doesn't mean you don't go as deep. You generally go deeper, but it's just an ordering issue, So we still have one of the deepest computational linear algebra courses around, and you'll learn how to do all kinds of matrix decompositions and implement them from scratch in your own code, which almost nobody teaches. In fact, for Rachel and I to get to a point where we could make that course, we had to write all this stuff ourselves from scratch because all the code we found was 30-year-old Fortran code, So you still go just as deep and generally deeper. But the important thing we know from research into learning methods is that the human brain learns better when it has context, when it has a reason to learn, when it understands the purpose of what it's doing.
Mm-hmm. Well, we'll dig a little bit more into education in a moment. I do want to pull in a couple of questions from our audience. There seems to be a lot of interest in embedded devices. So Bert is asking if you've worked with microcontrollers, and Kurti is talking about TensorFlow versus PyTorch for embedded. Is embedded something that you've seen folks work with the Fast.ai library on? Is it an interest of yours? What do you see happening in that space?
Yeah, so I've certainly seen it. And everybody I've talked to who has implemented or tried to implement TensorFlow or PyTorch on embedded or edge devices hated it. It's something. Is that
including like the TF Mobile and?
Yes, absolutely. Okay. But it's particularly on Apple devices. But most people don't have the luxury of only supporting Edge but not Apple devices. Mm-hmm. But it's pretty much everything. There's been this yawning chasm between the kind of the marketing that you'll hear from Microsoft and Facebook and Google about Edge deployment and the reality. And it doesn't matter whether you use Fast.ai or Keras or plain PyTorch or whatever. Unfortunately, the reality is if you want to deploy directly to an edge device, you have to convert your modules basically into a C or C++ format, generally through something like TorchScript or ONNX or whatever. Python is unfortunately a terrible language to build that kind of thing in because it's very dynamic. So TensorFlow and PyTorch instead have you kind of use a subset of Python and use kind of tracing or something like that to try to guess what a C++ version of that code might do. The guessing is very often wrong. It also requires linking to kind of pre-written C++ components. Then it kind of says, oh, look, Jeremy's calling this function now, so we know that we actually have to call that function on the edge device. And those layers are full of holes. They don't have all the functionality of the original libraries. So I always try to tell people avoid deploying to an edge device directly if you can, and if at all possible, have your edge device talk to a server over a network, which the vast majority of the time people can rewrite it to work that way, and that's just going to be much more convenient and things will just work. If you're going to do things in embedded or edge devices, just be ready for like a many month, if not many year journey. You'll find that the libraries don't really work. You know, they're full of holes and problems. They're not fully documented. It's still a mess. And it doesn't matter what you trained your model with, whether it was Fast.ai or a pure PyTorch training loop, or you used Keras with TensorFlow or whatever. By the time it's trained, you end up with just a regular module. There's nothing Fast.ai specific about the thing that you've trained. So yeah, train things in the most convenient way you can, and then be ready for a nightmare of trying to convert that into something that your embedded or mobile device will be able to run.
So you've kind of just gone through this iteration of all of the things that you work on, the courses, the library. What's the thing that's most exciting for you right now?
Oh my gosh, I don't know. Like everything. I mean, one of the things I'm most excited about is Nbdev, which is not even AI or deep learning specific at all, but it's like just being able to write software in a literate exploratory programming environment is wonderful. And I'm currently doing the V2 rewrite from scratch of Nbdev, just like I did a rewrite from scratch V2 of Fast.ai. You know, I kind of like to, for me, V1 of things is the bit where I kind of see that it works and see that people like it and, you know, get it out there. And then V2 is like okay, now with everything I know, what would I have done differently? So that's one of the things I'm most excited about. Yeah.
Nbdev grew out of the previous rewrite of the Fast.ai library. Is that right?
It grew out of Fast.ai V2. And it actually kind of grew out of the earlier Part 2 course. So we did a Part 2 course where we basically rewrote Fast.ai V1 kind of from scratch as the course twice. Once in Python and once in Swift. And the bit in Swift was with Chris Latner and his team from Google. And in the process of kind of rewriting it twice, we made it a lot better. And that was all done in notebooks because notebooks is such a good way to both to teach and to experiment. And so as we did it, we needed a way to turn those notebooks into libraries that we can like import into the next notebook so we can like move on to week 2, week 3 and so forth of the course. So we started building something at that time, and that worked really well, and we built a version of it for Swift as well, and it became clear during this time that, you know, I've been coding for well over 30 years, pretty much every day, and I've always been fascinated by the idea of literate programming, as Donald Knuth described it, this idea that you could kind of write prose, that we could kind of write something designed for humans and end up with something that machines can interpret. And I was also always very interested in environments like Mathematica, where you can kind of have things that were more interactive and more multimedia, and it included kind of collapsible hierarchies of things you could scroll through and look at. But none of those things ever quite worked as well in practice as I hoped, and I always ended up using, I don't know, Visual Studio or Delphi or Vim or whatever. But yeah, then suddenly I was finding I was writing stuff in notebooks, and it was everything that I'd wanted for decades. So so Sylvain and I decided to, step back and see if we could actually make Fast.ai v2 entirely in that way.
Yeah.
And could we write the entire book, an actual published O'Reilly book, in that way? And the answer was yes, we can. And so that's how Nbdev came along, and it's suddenly created this rapidly growing large community, and it's super cool. And so V2 is actually going to create a whole ecosystem where any Nbdev project can link to any other Nbdev project and kind of get all of its documentation and links and stuff like that. And I've also even created converters for the entire Python standard library for NumPy, PyTorch, and so forth, to kind of bring them into the Nbdev world as well.
You just mentioned some of the work that you've done in literate programming, and we're talking about Nbdev. Kai is curious, where does this all go? And do you push literate beyond Nbdev, or is maybe Nbdev 2 the next step in what you're doing there?
Right. Nbdev v2 is what's beyond Nbdev. It's this kind of, it's this ecosystem of Nbdev projects. It's also, hopefully bringing FastDoc, the book writing system, and FastPages, the article system, and Nbdev programming libraries more together. And also with Nbdev, I'm the rewrite is doing for Nbdev what I did for Fast.ai and what Sylvain worked on with me on Fast.ai, which is to bring a layered API to Nbdev. So there's going to be ways that you can plug into Nbdev to create your own, different Nbdev functionality. So yeah, hopefully we're going to see Nbdev keep growing and growing. And at the moment, it's kind of something which mainly people in the deep learning community are familiar with it, and hopefully we'll see more and more people from just general programmers building stuff with Nbdev too.
Mm-hmm. If I remember correctly, our first conversation, this would have been, again, October a couple of years ago, 18. You had just announced that the library would be rewritten, and that you would do that all in notebooks. I think you were some of the way there, because you had made some progress on the course, but hadn't pulled all that stuff out into Nbdev. And I'll be honest, I was skeptical that it would all work. I'm curious, what are the, you've talked a little bit about what some of the, what you like about those environments. Are there, drawbacks to that approach? Do you expect to see it, taking off more broadly? Are other folks, using Nbdev to do interesting things?
Yeah, I mean, there's certainly a lot of folks using Nbdev now. I don't have a list off the top of my head, but I'm seeing a lot of pull requests from different companies and a lot of people on the forums asking, questions about it, which are very clearly showing that they deeply understand it and they're using it. And, the challenge is it's directly against the kind of overwhelming direction of Python coding, which is Python is moving much more towards trying to become a static language with things like MyPy, or even things like Torch script and PyTorch tracing. These kinds of things only support a subset of Python, you know, a static, a non-dynamic subset of Python. And so increasingly I'm hearing people who kind of consider using the dynamic functionality of Python to be like bad, you know, or else to me, like, why would you use a dynamic language which pays a big price for being a dynamic language? Like, it is way, 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 way slower than any static language, like thousands of times slower, often at least hundreds of times. Like, so to me, like, you take advantage of that dynamic stuff, of meta programming, you know, meta classes and decorators, and, you know, make it sing. And Nbdev really is about making that environment work well, because Jupyter notebooks are truly live code. So when you do tab completion or whatever in a Jupyter notebook, you're seeing exactly what's available to you because it's an actual real live code object that you're interacting with. You don't have the guesses and hackiness of like MyPy static analysis or something like that. So everything we're building is around that, you know. So we also have this library called FastCore, which is a kind of suite of core pieces of functionality that one would want to when you're in that kind of framework. Yeah, but for somebody who has been told, oh, only the static part of Python is the acceptable part of Python, and, you know, you should be using MyPy and that kind of stuff, they're going to look at FastCore and Nbdev and think like, oh, that's not what I've been told real programmers do.
What do you think is driving that shift in the Python community? Is it, you know, folks trying to make it quote unquote grow up or get more enterprisey or something?
Yeah, it's folks that don't understand what Python is, like, but have been told that real languages like Java or whatever are, you know, these kind of statically typed languages. And so I'm increasingly finding a lot of people, you know, even involved in the Python core team, don't know any languages other than Python, but they tend to feel like a bit ashamed of how like not Java Python is, and they're kind of adding these Java-y things to it, and it's really not good for the language. So like take type annotations. Type annotations are fantastic, right? And in a dynamic language like Python, you should be able to do wonderful things at runtime with type annotations, which we do. We provide a Julia-like multiple dispatch system in FastCore. We provide automatic casting of types based on type annotations in FastCore. Like, there's a lot of stuff we do with type annotations. But Python has almost no functionality for using these types at runtime. And when you look at the actual mailing lists, everybody's only talking about static analysis with these types, which I just find crazy, you know, because you can't do it properly, you know, and to do it even vaguely properly, you have to turn Python into a language it's really not, and then you end up with just a really slow version of Java. And not only slow, but a really clunky version where you have to explicitly annotate everything with types, where else every other language is moving away from that to doing automatic type inference. And in Python, we don't need it because we can actually do things at runtime.
Now, you're a bit of a aficionado of languages. We've talked and you've referenced APL in the past. I remember when we were first doing the study group around the course, there was a conversation happening in our Slack about how your choices for variable names were unusually terse, and someone observed that you were very deeply involved in the Perl language at some point, and that, you know, maybe had something to do with that. And about maybe a year ago or so, you got really excited about Swift, and we talked a little bit about that, rebuilding that V2, not the V2, was it? The versioning around the courses in the libraries confuses me sometimes. It was the part 2 of the V2 course, I think.
Part 2 V3, I think. But yeah, anyway, I know what you mean. Yeah.
So part 2 of that course you rewrote in Swift, and we got a couple of questions here about kind of where you see the whole language landscape going. Curti's asking, what do you think about Julia and Swift for TensorFlow, or Swift for TensorFlow? And Pablo is curious, are you planning to migrate completely from Python to Swift in Fast.ai? You talked a lot about some of the things that you like about Python, and you certainly built quite extensively on it. Where do you see all that going?
Yeah, so Python is definitely the best language for deep learning right now, but it also definitely won't be in the long term. The limitations of the language are fundamental limitations in the design. I mean, I shouldn't say they're limitations exactly. They're constraints built into the design. And so we have things like the global interpreter lock, which means that multiprocessing, or really multi-threading, is incredibly painful, and to do it with any reasonable amount of performance is very complicated and very verbose, and very hard to debug. And multiprocessing is just such a fundamental thing now with multi-core processors we all have, and particularly GPU, which you have thousands of things going on at once. It's so I'm certainly looking for what the future is, but that's years away. But I want to be ready for it. Swift, it was a huge blow that Chris Latner left Google, and that didn't kill Swift for TensorFlow, but it certainly injured it deeply. He was really driving so many of the best ideas there. So I still hope, there's still some great people working on that, and I hope it's going to be terrific. But I'm certainly not as enthusiastic as when Chris was there, for sure. Julia is the other really interesting language in this space. Swift and Julia both, as languages, are fantastic languages, and they both have what's needed for whatever the next post-Python language will be. It's early days for Julia. It's early days for Swift as well, particularly Swift outside of kind of iOS programming. It's at the moment, it takes quite a long time just to run a Julia process. It takes a huge amount of memory. These are not but the good thing about Julia is these are not fundamental limitations in the language. They're things that can and are being fixed. The really cool thing about Julia is that nearly all of Julia is written in Julia, which unfortunately is not where Swift is. It's certainly not where Python is. Python, almost nothing's written in Python. When you're doing data science, everything you do is hitting Fortran or CUDA or C code straight away. Julia is amazing. It's a little scheme parser that's kind of converting what you write in Julia into something that gets fed to LLVM, and then really everything is built in Julia, which I think is super cool.
I'm glad you have nice things to say about Julia, because Julia does have a very vocal group of supporters.
Yes,
we did a language debate not too long ago on the show, actually in a similar format as this, and the Julia posse was super vocal.
So funny. It's kind of like Lisp people used to be,
Uh-huh. So for a while, a lot of the interesting things that we would talk about when we connected were things that were happening super low down in the kind of the deep learning stack. Like the last time we spoke, we were talking about, or the time before that, we were talking about things that you might think of as kind of minute details, learning rate cycling, and dropout schemes, and optimizers and things like that. Chandra is asking, what do you think are the most interesting deep learning research areas right now? Is it still like super low in the, trying to figure out how to make training work at a basic level, or are there other areas that that you're looking at now and seeing as being?
Yeah, unfortunately, there hasn't been much more development in that low level stuff. Dealing with those kind of hyperparameters is still more clunky than it should be, unfortunately. And there's still very, very, very few people doing research in that area. It was really Leslie Smith was the guy who did nearly all of it. The thing I've been most excited about recently is self-supervised learning. So it's kind of taking these ideas from ULM fit around like language models, which kind of became GPT and GPT-3 and BERT and so forth, and thinking about doing similar things in other areas. And so self-supervised learning and contrastive loss is allowing us to do more with less. We can beat previous data results with 10 times less or even 100 times less data. And I think that's very exciting.
Are there examples outside of language models that you think are interesting showcases for where self-supervised is, or where the opportunity is?
Absolutely. Yeah, absolutely. We have a paper hopefully coming out soon that shows how that kind of approach can dramatically improve microscopy super resolution. There's a lot of papers that have come out in the last 12 months showing dramatic improvements in classification in computer vision. So for example, I have a blog post about it actually, self-supervised learning in computer vision. If you look at our ImageNet and ImageWolf benchmarks, the leaderboard, all the top ones in the leaderboard are now using self-supervised learning. It's such an easy thing to add as well, which is really nice. Whatever it is you're doing right now, you can add self-supervised learning to it and get generally much better results. It's particularly helpful in stuff like medicine, where there's very few pre-trained models. You can kind of treat it almost like a pre-training step, even if you don't have a pre-trained model.
And you mentioned a second thing that I didn't catch.
Contrastive loss. So, I mean, that's just a particular approach within self-supervised learning that can make self-supervised learning quite a lot better. So generally you have some kind of data augmentation, and part of your loss function is basically just to have something that's being able to tell whether something was augmented or not, and make sure that the augmented one and the not augmented one give the same answer. And it just feeds a huge amount of more signal back into the model. And again, it just means you can use orders of magnitude less data for the same or better results.
The most recent version of the course has been out for a while. What kind of feedback are you seeing from the latest iteration?
It's been amazing, actually. I mean, both the course and the book, in terms of just what, just the ratings it's getting, like over 99% of people on YouTube are giving it the thumbs up. The book has 5 stars on Amazon. And it was also cool. I sent the book, along with some of the folks at O'Reilly, sent the book to a bunch of really big names in AI and ML, and nearly all of them sent back a review. And yeah, it was great to see like people I have admired for decades writing how much they loved the book. It's people obviously we know they love the content in terms of the top-down approach, and the very kind of thoughtful to students, very empathetic approach to teaching. But I also like to hear back just people really appreciating the time we put in to just stuff like formatting. Not just the paper book, but the ebook as well. Like the images are super high quality. The code, you can copy it out of the Kindle version.
That's pretty amazing.
The whole thing's in color, and the paper book's all in color. The index is really carefully put together. It's just one of we and O'Reilly tried really hard to make it the best we can make it. And so when I hear back from somebody, like for example, chapter 4 is this. It's something I've been working on for years, which is basically starting with nothing at all and saying, how would we build something that can do MNIST? And you start with like 0. And try to make it that at every step, it's like, we start with something that literally just takes the average of the pixels for the 3s versus the 7s and figures out which is closer to the average. And then gradually works away from there until by the end of the chapter, we have a actual deep learning model and a training loop and a data loader. And yeah, somebody just kind of left this feedback saying like, I can't, this just feels like you've taken decades of study and distilled it down into a single chapter. And I was just like, oh, I'm so glad they noticed, because I rewrote that chapter literally dozens of times, and it's based on things that I've written previously dozens of times over many years. Mm-hmm. So yeah, it's been great when people appreciate the hard work.
That's awesome. What's next for the course?
Nothing's decided. We need a new part 2, obviously, which we still have about half the book to cover in the course. So we'll be covering the other half of the book, but hopefully also covering some stuff that didn't make it into the book as well. So it'll be, the more advanced, deeper dive into architectures and, other more detailed topics.
Yeah, I'm curious your take on, so you've got an array of courses at this point. There's the machine learning course, which maybe is integrated back into...
That is now officially obsolete on the whole. Yep, that has been integrated back into deep learning for coders.
And the NLP course as well, is that...
it hopefully by the time we finish part 2, it will be, except the NLP course has kind of pre-deep learning NLP stuff around like topic modeling approaches and so forth, which you kind of need to know in order to pass an exam, or maybe even to like get through an interview with a pre-NLP, modern NLP interviewer or something. So that's why we taught it. But you don't really need it that much in practice. Like you're not generally dealing with lemmatization and stop words and stuff like that. So yeah, we're not going to integrate in some of that stuff, which I think is basically obsolete anyway. We will be bringing much of that NLP course into part 2 as well.
Mm-hmm. Great question here from Sanyam. Can you give us a peek into the way you go about creating kind of these top-down materials and courses? Is there a way of thinking that you need to adopt? Certainly, you need to let go of the idea that you have to build everything up from the foundations, clearly. But are there other things that you think about as you're pulling these materials together?
It's a great question. I find it extremely difficult. I always default to teaching bottom up because it's just so much easier when you've got to the point of understanding something well enough that you're ready to teach it. It's so easy to teach it bottom up, because that's the way it sits in your head into this kind of hierarchy. And so it's so easy to say like, okay, here's this like low level thing, and then there's other things built on that. There's other things built on that. There's other things built. In 6 months' time, you eventually say, "Do you remember that low level thing I showed you 6 months ago? This is how we actually use it." And my wife and I talk about this all the time because we both struggle with this. Is that it's so much harder to teach top down, and so we often have to like tell each other off. Say like, "Oh, what do you think of this article?" We're like, it seems pretty bottom up. And it's like, oh, yeah, I suppose it does. But, you have to come up with the junior version of the game. It's like, how do you show off a complete end-to-end thing that doesn't require all the knowledge? And often that does require, writing new software. It requires writing new approaches. Sometimes it requires fundamental research. It's really, really difficult.
I'd love to hear you talk a little bit about community and what that means to you. I remember a tweet that you posted, I don't know, it was maybe a few months ago, where you shared a screenshot of your Fast.ai community stats. And,
all right.
As an example, I think, of articulating, conveying just what goes into kind of building and maintaining a community. I've got so many questions, starting from why do you do it? What does it mean to you? Where do you see the role of community being in what you're building around Fast.ai? I'll leave it at those for now.
Well, yeah, you know what it's like, Sam. You've done so much for building your community, and it's just a ton of work. This goes back, a long way for me. Like Fastmail, the email company I built, I made a conscious decision to use a third-party web forum as the kind of main support channel for that, because I wanted to be like super transparent, and I didn't even have moderated privileges, so like anybody could know this is the unvarnished truth about what's going on with Fastmail, because people are asking these questions and here are the answers. And over a period of some years, I had something like 100,000 posts on this forum, and it was absolutely the most bustling community for email discussions in the world. And yeah, having a forum like that, it's so important, because you otherwise you kind of live in this this world in your head. You don't know how people are using your software. You don't know if it's any good or if people are liking it. You don't know what problems they're having. So an online community is a great way to keep yourself grounded and to and then it's got this great high leverage thing going on, where the more people in your community, the more useful that community is, because people are answering each other's questions. And so, I've noticed quite a few of the questions on this today have been from folks whose name I recognize from our community, and they're folks who have helped other people in our community. So in the end, I think it's great for me. It's great for Fast.ai. It helps create this kind of self-perpetuating cycle of helpfulness. I do find it requires, a heavy hand around, like, making sure that people are being kind and helpful. There's definitely a tendency otherwise for the most toxic and abusive members to have everybody else run away, and then you end up with the only people left are the ones who are, equally argumentative. So I certainly work hard to, ensure people remain kind and generous and respectful. But it requires very little intervention, but the intervention needs to be swift and direct,
Maybe switching gears a bit, you got involved very quickly in the in raising awareness around masks for COVID, and kind of dove into that. Now that we've got some 6 months kind of experience, I'm curious what your reflection on all that has been, and where you see just what that experience has meant for you, I guess.
Sure. Yeah, I mean, the experience itself was mainly deeply unpleasant. Masks are boring, and trying to convince the world of something which they don't believe to be true, and not only that, but they think is stupid, is really stressful, particularly in the early days. Having said that, there was a lot of wonderful parts of it, and particularly I got to meet and work with some really inspiring and terrific people. Folks like Nbdev and Trish Greenhalgh, Vincent Rajkumar. It was cool to become enmeshed in a whole different community. The community of doctors and evidence-based medicine specialists and so forth, and made a lot of friends in that community. And the nice thing is that these people, a lot of them have become pretty famous, because eventually we were very much shown to be right, and now people are kind of saying like, oh, who were the people who told us this? And so I've had numerous newspaper articles written about me and that journey and the people I did it with, and so it's kind of cool to see that appreciation. But overall, it's something I would never want to do again. Especially me, I'm actually pretty introverted, and to have to force myself day after day to do TV and radio and act, confident and upbeat, and no coding, no coding for months. Didn't really suit me at all, but I'm glad I did it. It was important, and now when my 5-year-old daughter sees people not wearing a mask, she'll say like, "Dada, why are they not wearing a mask? I thought you told everybody in the world about them." I'll be like, well, some people aren't listening.
Wow. Well, Jeremy, I've thanked you before for all of the work that you do, and the courses, the materials you put out there. If you're seeing the chat, there are lots of other people that are grateful for the work you're doing.
And you, Sam.
Thank you. And thanks once again for, taking some time out to chat and share about.
All right. Thanks for having me.
Awesome.
Congrats on the great event you're putting on. I think this viewing is going to be fascinating of this new film. I can't wait.
Yeah, we're excited about it. Yeah. Thanks so much for participating, and thanks everyone for joining us. And check out the agenda for more TWIMLfests through the month of October. Take care, everyone.